Yes, guys, today we've got question 21 from the most recent SMC paper. So we've got a hexagon inscribed within a circle which has radius 5. Point X on the circumference of the circle is connected to the vertices of the hexagon to form 6 chords XP, XQ, XR, XS, XT, XU. What's the value of all these squared and summed? So let's get a bigger picture of the diagram. Right. So we've got any random point just on here, and we're expected to find the sum of all these lengths, all these chords. But in a question like this, they don't specifically say where this point is. So let's put it on the, let's write in red actually. Let's put it on a vertice. The reason we do this, well, it makes it so much more easier to deal with the lengths. Like we'll just have to find this side, this length here, this length, which is just the diameter of the circle, this length here, which is the same as this length, and then another side length. Well, if we go back to a hexagon, right? A hexagon is made up of equilateral triangles. So let's go here. That's the center. So that's the same as that, it's the same as that. That's 60, these are all 60 degrees. So we can comfortably say that all the lengths of the hexagon are just 5, as well as the radius. So that's 5, that's 5. This one here, on the other hand, well, we can just, if this is 5, we just need to find the base of the isosceles triangle. So we know this angle here is just 120 degrees. So if we drop an altitude from here, we have 60 here, 90 there, and 30 there. 60. Well, we're using our 30, 60, 90 triangle ratio idea. If that's 5, that's 5 over 2. That's 5 root 3 over 2. Since we've got 2 of these, this whole length is just 5 root 3. And then that means this here is also 5 root 3. So let's just rub all this out now. We've also got this diameter here in the middle, which is just, well, diameter just double the radius, that's 10. So now we need to find the sum of all these values squared. So let's go to the side. We have 5 squared twice, so 2 times 5 squared, plus 2 times 10 squared, plus 2 times 5 root 3 squared. 2 times 25 is 50. 2 times 100 is 200. And then 2 times 5 root 3 squared, well, that is just 25 times 3, 75. Well, 5 times root 3 squared is 25 times 3, 75, plus 150, which equals 400. And I found that this is wrong, so we made a mistake somewhere. I think this value here is wrong, so that means we've calculated this side length incorrectly. Why is that? Well, let's just take this isosceles to the side. So we had 5 here, 5 here. We had 60, we had 30, 5 over 2. We have 5 root 3 over 2. So then we had 5 root 3 in total. What has gone wrong? Yeah, it was 400 isn't even one of our options. cannot see what's gone wrong here. But anyways, we can move on to the second method I was about to show, which will probably get the right way. So let's bring this back. And instead of just choosing a vertice for a point to be on, let's pick out just any other point on the circumference. Now let's start drawing on points. There we go. The first thing to notice here that let's take a look at, let me just see, right, yeah. Let's start constructing on the diagonals of this hexagon, or also the circle. Now why is this useful? Okay, we made the diagram slightly more confusing, but that's fine. Well, notice that we've got, actually let's just remove some of the diagram, so we're left with just that. So this is two of our desired lengths and a diagonal that I've drawn on. Now we know that since this is the diameter of the circle, this angle here must be 90 degrees, meaning that let's call this xp squared plus xs squared equals, well, just the diagonal squared. And we know the diagonal just to be 10, so let's write that up there. D equals 10. Now xp and xs, if we've got a pair, well, that's just 1 and 2 done. So we can just use a similar argument for the other. So let's use the second diagonal over here. Now from here we can find x was here. We can get xu and xr. xu plus xr squared, which is again d squared. And for the last one, well, we can just use a similar argument. xu, xr, we have xt and xq. So xt here plus xq squared equals d squared. But if you add all of these up, this is what the question is asking for. This question, or we say the solution, just equals 3 times d squared. Well, d squared is just 10 squared, so that's 3 times 100. Therefore, we have 300. So this was the more elegant way of solving this problem. You just had to notice that we could pair these with a diagonal of our circle and then use Pythagoras to just simply get 3 times the diameter squared as a final answer. And that's it. Not sure what went wrong here, but hopefully I'll be able to find the mistake. Right. Thank you for that then. Goodbye.